All right, so now we have all the ingredients for logistic regression, and let us see how logistic regression arises and how it is trained. So what the loss function for the logistic regression is. Now, so we have two possible outcomes, 0 and 1, right? And generally speaking, the outcome of our classification model is a vector with two entries, right? So, but since we are doing binary regression, so let us yi hat to be just the estimated probability that y equals 1. Now, so let us use the small p of x as the estimated probability that y is actually 1, right? So the difference here is that the small p of x is the estimated probability, is whatever our model outputs, and the big P here is the true probability. Okay, now, so logistic regression is actually a model for binary classification. This is important, so I'm going to repeat it. It's not a regression, it is a classification model. So it is called regression, but it is actually a classification model. So, and what we do for logistic regression, we just fit a linear regression for log odds of our P of x. That's the idea. But sorry, it's not exactly the idea. So we kind of, that was the original idea, but then we're going to change it a little bit. So we are going to use a different loss function, because for linear regression, we are using the mean squared error. So for logistic regression, instead of minimizing the mean squared error, we are going to minimize a different function. So what is that a different function? Where does it come from? So, and it's actually a pretty simple but very powerful idea, is that suppose that we fix some value of beta, right? So we have some fix some parameter value. So beta is like, I don't know, beta 0 hat, beta 1 hat, and so on, right? So we fix some values, right? So given these values of beta, so we can compute probabilities of observing any possible outcome, right? So our P of xi now is the probability that that our yi is 1, right? So which means that 1 minus P of xi is the probability that yi is 0, right? So, but now if we multiply all of them, then we will get the likelihood of observing the outcome that are actually observed in our training data, right? So, and the idea is that we are going to maximize the likelihood, right? So we are going to find parameters of the model, so beta, so that observing the outcomes, the training data, is as likely as possible, given beta. Well, but maximizing this likelihood is, of course, the same as maximizing logarithm of that, because logarithm is an increasing function, right? So our loss function is going to be, well, since the idea is that we are minimizing the loss function, so we are going to minimize minus logarithm of the likelihood, right? So, and minimizing the loss function is therefore the same as maximizing the likelihood. So let me derive this loss function, right? So it's going to be minus log of the likelihood. So my L of beta is going to be minus log of my likelihood, L of beta. So L of beta is written here. Well, but log transforms product to a sum, right? So this is going to be minus the sum of log of P of xi minus the sum of log of 1 minus P. I'm not going to write xi. I hope it's all right. So, but this is, so notice that this is the sum taken over all I such that yi is 1, and this is so this sum is taken over all I such that yi is 0. But we're going to slightly modify it just a little bit. So instead of taking the sum over just those yi for which yi is 1, we're going to take the sum over all I from 1 to n. And we're going to multiply it by yi, right? Because now if yi is 1, we just get it the same as before. If yi is 0, then we will just get 0, and it's not going to contribute to our loss function. So log of p of xi minus, by the same logic, we are going to have the sum of 1 minus yi times log of 1 minus p of xi. Okay, so this is how it works. In any case, this is the answer again. So the logistic regression is the model where we fit a linear regression into, well, we fit log odds of our probability as a linear regression, but we use a different loss function as not the mean squared error, but this formula. And if you think a little bit about it, you will realize that this loss function is actually just the cross entropy from lecture 1. And it is also called a binary cross entropy. So when we just have two outcomes, then it's a binary cross entropy. So this is where cross entropy comes from, because it is the loss function of the logistic regression. Well, because this is the loss function that comes from maximizing the likelihood of observing the data. Well, now logistic regression is trained by some version of gradient descent. We are going to derive the gradient of the logistic regression in tutorial. Now, what is important is to know that the loss function here is in fact convex. So it looks like this rather than like this. So that there is a unique point of minimum. And if we fitted it using the mean squared error instead, then the loss function is not convex anymore. So it could be something like this. So here is a little quiz for you.